Hello everyone, my name is Adarsh and this is the video demonstration of task 1.1p of SIT315. So here is the code for this. Now let me explain what is happening in this code. First we have a namespace my program is defined, which is encapsulating class program. The class program is defined as internal, meaning it's accessible only within the same assembly. Then we declare three variables n, x and y to represent the size of the grid and robot's coordinate. An enumeration direction is declared to represent the direction north, east, south and west the robot can face. After that we have a public static variable current direction of type direction, which is declared to hold the current position of the robot. Then we define some methods like left, right and forward. Left method basically turns the robot left by updating the current direction variable. Similar goes to the right, it turns the robot right, and forward moves the robot forward by one step based on its current direction by updating x and y. Then I've also implemented a display matrix in this code which will display the grid with the robot's current position marked by R. So now let's go to the main method. Here is where the main program execution starts. First, user is prompted to enter the map size. Validation loop ensures the grid size is within a valid range, which is between 2 and 10. After taking the input, we can see we are shown with the message your robot is ready to place. If user places the robot outside of the boundary of the map, then the robot will be placed to the nearest boundary. The robot will be clamped to the nearest boundary. Like if user wants to enter the coordinate 30 and 30 of map 20 into 20, so he will be placed to the nearest boundary, which will be 20 and 20. We have done this by using math clamp. After that we can see user is prompted to select the direction for the robot or to exit. A loop continues until the user selects to exit. User input is processed and the corresponding action, which is to turn left, turn right, move forward, is performed. The grid with the updated position of the robot is displayed using display matrix. Then the current direction is updated. User is prompted to select the next action of the robot. This program essentially stimulates the movement of a robot on a grid based on user input, displaying the grid and the robot's position after each movement. Now let's run to the output of this code. Here we are asked for the map size. Let's just say I want 20 map size. Now we are shown your robot is ready to place. We have to select its x and y coordinate. Let's just say I want to go, I will enter a map size 30 by 30. I will place robot at 30 by 30. So here you can see robot is clamped to the nearest position, which is 20 by 20. Now let's just say we want to do an action like move forward. We can see here is our display matrix, and here we can see the position of our robot. Our robot is currently facing north at coordinate 20 into 20. Now let's perform some actions here. Let's first move left. Now our robot is facing west. Now let's just move forward. As you can see, we're successfully able to do it. Now let's move to the bottom side of the map. Now our robot is facing south. Let's now move forward. As you can see, we are successfully able to do it. Now let's go to the right side of the map. Now our robot is facing east. Okay, now let's just select the next robot direction to be right. Now our robot is facing south. Let's now move to the bottom side of the map. As you can see, we are successfully able to do it. Now when we press 4, we will be successfully able to exit. But first, let me show you what happened if we try to go to the boundary. Will be able to bypass it, or error shows? Let's just see. As you can see, the robot will not move forward. It will stay in the position. It will not go outside of the boundary. Now let's exit this code. Again run it. Now let's just say we enter an invalid map size. As we have shown, it is between 2 and 100. So let's say we want a map of 200. We are prompted with a message invalid map size. Now we have to enter a correct map size. Let's just say 4. Our robot is ready to place it at 2 and 3 coordinate. Our robot is ready. Move forward. Here we can see the current position. Move left and now move forward. As you can see, our code is working. Now we press 4 and exit the code. So this is the video demonstration of my task. Thank you.